My name is Jacob Colgrove. I'm Assistant Product Manager here at Redline Controls. And in this video, I'm going to show you how to connect a RAM 9000 cellular RTU to the AT&T M2X IoT platform using the RAM QTT client driver in the RAM 9000. First, I'll show you how to configure the AT&T IoT platform to accept incoming connections. Then I'll show you how to configure the RAM 9000 so that it can initiate an encrypted connection over to the AT&T IoT platform. So let's start off by configuring a device in AT&T IoT platform.
Log into your account at m2x.att.com. Since the RAM 9000 is going to automatically register with the M2X IoT platform, all we need to do is get the master key. To do that, click on the Skip Setup button to get to the main portal. Then click on the Settings button in the top right hand corner and go to Account Settings. There you'll see the master key. Highlight that and copy it. We'll use that in the RAM 9000 RAM QTT configuration setup.
Now I'll show you how to configure the RAM 9000 to initiate that connection to the AT&T IoT platform.
Now go to the RAM 9000 web user interface and go to Services RAM QTT Client. To enable RAM QTT, select Yes. Then for the IoT cloud, select AT&T M2X. The default broker is api-m2x.att.com. To enable a secure encrypted connection, type 8883 for the port and Yes for encryption. Leave the registration to auto to have the RAM 9000 automatically register with AT&T, and then paste in your master key into the master API key field. In this case, the distribution ID can be left blank, but it would be used if you were using the AT&T distribution feature. The minimum publish interval time is used to set the minimum amount of time that the RAM takes to send its data. Messages are only sent when values are changing in the RAM 9000 I/O. So this setting can be used to conserve on data when the values are changing very frequently. I'll set 5 seconds here, but typically a longer setting would be set to limit data usage. The device info message dropdown gives you the option to send a predefined amount of information from the device, like serial number or cellular IP address. Select none if you don't want any of this information sent, and select basic if you want a subset, or full if you want all the information sent. A full list can be found in the help button. The device information publish interval sets how frequently the device information message is sent. The keep alive setting sets the minimum idle time between the RAM 9000 and AT&T before an empty packet is sent. The retain messages setting allows new subscribers to receive the last message sent instead of having to wait till the next message is received by AT&T. Track server responses allows for more detailed error messages, but increases the message overhead. And the use message history records the I/O changes between the minimum publish interval. Now we'll add some I/O so that the RAM 9000 sends the I/O to AT&T. I'll first select the first discrete input. Then I'll use the filter and enter time to enter the clock time in seconds. This way we can see the time increase in the AT&T IoT platform. Now click the Test Server Availability button to test whether the connection is successful. When a successful connection is made, click on the Apply button to save the settings to the RAM. Once the configuration is saved, you can click on the Show Status button to see the status of the connection. Click on the Refresh button to get the latest information, and there you'll get connection information like connection status, the estimated data usage, and the last message sent. To see the I/O values sent from the RAM device to AT&T, go back to your M2X portal. Click on Devices to see the new device registered by serial number. Expand that to see the I/O that it sent. Then click on any specific I/O point and you'll be able to view the status of that. So what you'll see here is the time_second variable updating every 5 seconds, increasing to 60 and then back to 0. This shows us that our minimum publish interval time is working at 5 seconds. Now I'll click on my DI1 input point, and you'll see when I turn the input on my RAM 9000 here, the graph will go to 1, indicating that it's on. When I turn it off, it'll go to 0, indicating that it's off.
So as you can see, connecting the RAM 9000 to the AT&T M2X IoT platform is easy. For more information and tutorials, please go to www.redlion.net.